So, hopefully you've watched kinematics 1, about 5 minutes long, kinematics 2, about another 5 minutes long, vectors, which I think will be about 5 minutes long. Vectors, measurements with magnitude and direction. We talked about your list of vectors. Vectors will move fast in a given direction. And again, you know there's a velocity. I wanted to review this because velocity is measured in units. Anybody know? Yep. Meters per second. I heard that. That was, I think that was Carissa Comfort. Thank you, Carissa. And then weight is measured in newtons. Dustin, thank you. I heard that. Okay, next. M is momentum, not mass, because mass is just mass. It doesn't have a vector direction to it. Momentum has direction. You talked about the momentum shifting from one team to another. The units for that are kilograms times meters per second, mass in motion. Very good, Sabrina, I heard that. Now, the next thing, Cody Dondero, Cody, force measured in newtons. Very good, Cody. And, what's that? Sadie? Yes, Sadie, that's correct. Impulse is newtons times seconds. If you look, it's force times time. It's not only a push, but it's a follow through with a push and a certain amount of time that you're going to act. Acceleration, meters per second squared. I heard all the students together shout out for that. And gravity is also an acceleration, meters per second squared. And then, what? Nate Ripley? Meters for displacement. And remember, displacement would be your straight line distance from start to finish. If you forget that, I've said it 3 times, you really haven't been paying attention. Now, we need to work with vectors at 3 different angles. Okay? Those 3 different angles are 0 degrees, 90 degrees, and 180 degrees. So what will happen is, say for instance, ATV is being fought over by 2 girls. Now, ATV, we're going to call him this green guy right here. Okay, we're going to give him some green hair this time. Okay, so that's the top of his head looking down from above. And if we have 0 degrees, like say for instance, we have Aretha is pulling, so she's going to be A, and she's pulling with 200 newtons. And by the way, a newton is a quarter pounder with cheese, about 1/4 of a pound, so 200 newtons is about 50 pounds of force. And then also Bertha, of course, is pulling at 250 newtons. Then the resultant force here would be, yes, 450 newtons is the magnitude. And then to the east, because it's going to the east side, like that. Now, 90 degrees. Let's say she pulls, Aretha pulls at 200 newtons this way, okay? And then Bertha pulls 250 newtons this way, 250 newtons. Then now we're going to have a little bit of calculation to do because it's not just simple add it up. So I'm going to grab my handy dandy calculator. I'm going to do a squared plus b squared equals c squared. So at 0 degrees you add them up, right? 90 degrees you do Pythagorean. So let's see here, 200. I heard Aretha is actually very beautiful. So I'm going to take the square root, second, where am I? Right there, x squared, second, answer. So 320. So the resultant here is 320, I know it has some change, 320 newtons to the southeast. Now if along comes a C girl, let's see, let's call her Camila. If Camila wants to balance out what Aretha and Bertha are doing, she'd have to pull 320 newtons to the northwest. Very good. Now 180 degrees. Aretha, Bertha, resultant, 50 newtons to the west side. Very good. That is the overall sum of working with angles for vectors. Concurrent forces are acting on the same object at the same time. Right here I demonstrated tail to tail for each of these, which is the parallelogram. If you did head to tail, which is something like this, you would typically use the triangle method. And in your packet you'll see an example of that. The other thing we need to know, a couple other things actually we need to know about for vectors is how to work with the y component, the y sign, as Mr. Norman likes to say and I like to say. It's something we have in common. besides being fancy dressers. And then your AX is going to be the cosine component. So for instance, what we just did was combining two vectors into one. Vector marriage. This, unfortunately, is a little bit of vector divorce. We don't like to talk about that. It's messy, but it happens to vectors at times. So if you have a vector at an angle, any vector, vectors will move fast in a given direction. Any vector could be in there like a force or a velocity or something like that. This would be your horizontal component. Catch what I just said, horizontal, like the horizon. Like Poppy and Tommy like to watch the sun go over the horizon. Okay? And then vertical, if you've got vertical jump, you're going up this way, and this is your angle right down here. Now remember, if you want to find the vertical, it depends on the y sine. Okay? And then if you want to find the horizontal, it depends on the much more boring cosine component. And what mode are you in, kids? I don't have my degree antiperspirant, but you're in degree mode. We'll pretend this is a degree antiperspirant. So degree mode is what you use. Not radians. Radians are bad. Don't use radians. Degree, good. Last thing here is a free body diagram. And you'll see examples of that, by the way. I just don't want to take time for this one. So free body diagram, like say for instance you have a box full of Barbie dolls. Okay? So say you're at Dylan's house and Tinky comes over to play with Barbie dolls with him. Well, he's got a box full of Barbie dolls. What's going to happen if we draw a center of mass right there, a dot representing the center of mass, if you were to concentrate all the mass in one point? Then we'd have this force right here called the force of gravity, or sometimes we use little w, which, by the way, if we wanted to calculate it, remember you need to remember is W equals mg. This force right here, this is the one that a lot of people forget, but I need you to remember. It's the normal force. It's not normal for the weight to fall, for this box of Barbie dolls to fall through the floor here. Okay? It's more normal for the floor to support that weight. So that's the normal force. And so these two forces canceling out are in equilibrium. Now there's two types of equilibrium, and those two types of equilibrium we'll get to with Newton's laws. So I'm stopping this for now. That is vectors. Thank you.